Hello viewers, I am Kausalya. Today we are going to solve Bode plot problem number 9 part 2. The problem is draw the Bode plot of the open loop transfer function and this is the given transfer function. In part 1 we had find out the different values of magnitude for different frequencies. Now we are going to proceed with phase plot. So for phase plot this is the given problem. I have replaced S by j omega. So now we are going to frame an expression for phase plot. So the thing is we have to start with individual omega and a constant term will never contribute any angle. So here an omega always contributes an angle of 90 degree. Since it lies in denominator, it produces an angle of minus 90, right? So that is my first term. So here this is minus 90. The next thing is, again we are considering the denominator term. So tan inverse of imaginary coefficient divided by real term coefficient. So here the imaginary coefficient is 0.2 omega divided by the real term is 1. So tan inverse of 0.2 omega. Again this is a denominator term. So here I have included a minus sign. And when we move denominator to the numerator, a minus sign must be included. Again when we move to the third term, the same thing, tan inverse of imaginary coefficient is 0.05 omega divided by the real term is 1. So again this is a denominator term. I am moving this to the numerator. So here I have included a minus sign. And again we are having one more term in the numerator, right? So here since this lies in numerator, here I am having a plus sign. So tan inverse of imaginary coefficient is 0.1 omega divided by 1. So here I am having tan inverse of 0.1 omega. So this is our expression for the given problem to find out the different values of phase angles. Now we are framing a table. So this is our table. So in this table we are going to select different values of frequencies and we are going to find out the values of the angles. So here while considering this frequencies, we have to include all the 5 frequencies which we have used for our magnitude plot. Apart from that, we can include the in-between values and a value higher than the frequency also, right? Minimum having 7 to 8 values of frequency in phase plot will give you a more beautiful phase plot. So here the different values of frequencies here is, it is 0.15, 10, 20, 100. So here I have included all the values. You see 0.15, 10, 20 and 100. Right. And you can include the between values also. And finally by using a calculator, here I had find out the values. Right. Here just by using calculator you can find out, nothing is going to be difficult for you. Now we are going to plot these values on a semilog sheet. So this is our semilog sheet and in x-axis we will be always having frequency. You see here I had written log omega. And in y-axis on this left hand side we are considering magnitude and in the right hand side we are considering the angles. So depending upon the values we have to adjust the scale here. So here I have taken the values as 0, 20, 40, 60 and minus 20 and minus 40. Now we are going to plot the values. So what is the first value of magnitude? Here at frequency of 0.1 the magnitude is 46. So here in x-axis we usually start with 0.1 or 0.01, okay, anything is good. So here it is 0.1 and this gets multiplied by 10 will give you 1 and this 1 gets multiplied by 10 give you 10 and 10 gets multiplied by 10, 100 and it goes on, right? Because here we are considering decibel per decade, okay, here decade refers to 10. So now I am going to plot the first point at a frequency of 0.1, right, the magnitude is 46. So here this is my 40 and this is my 60. So between these two lies 46. So here I had marked that point. And the second one is at a frequency of 5 the magnitude is 12. So you see between 1 and 10 lies 5, right? So now I am going to mark this point. The value is 12. So here between 0 and 20 lies 12. So you see at a frequency of 5, we can look at here. At a frequency of 5, here the magnitude is 12 and this is my second point. And the third one is at a frequency of 10, the magnitude is 0. So you see here I am having 10 and the value of this magnitude is 0. So here I have marked that point, right? Similarly, we can plot the rest of the points and here we must use a scale to join these points. So even we can give name to it. Here let it be A, B, C, D and finally E. By using a scale, we have to join the points here. So, between A and B, okay, join, and again between B and C, and between C and D, and finally D and E. Right, so this is our magnitude of the given Bode plot. Now we have to mark the respective slopes. For marking the slope, we have to look back at our table. So here what is the first value of slope? It is minus 20. So here between A and B, we have to mark it as minus 20 decibel per decade. Right. And again, what is the value of the change of slope? It is here minus 40. So we have to mark it. So between B and C, this is minus 40 decibel per decade. Right. Then the next value is minus 20. So here we have to mark it as minus 20 decibel per decade, and here the final value is minus 40, and minus 40 should be marked here, minus 40 decibel per decade. Right, so this is our magnitude plot for the given problem, and the main thing is we have to always highlight this 0 dB line. Right. So finally magnitude plot is drawn here. Now we are going to make our phase plot. Here again in this right hand side of y-axis I have taken angles depending upon the values in the table. So here I have scaled as 20 degrees, 80, 100, 120, 140 and here 180. Here everything is in minus. Right. Now we are going to plot the points here. So when you plot the points, as usual, here the first value is at point 1, the angle is minus 90. So you see here I am having point 1 and here you see here lies 80 and 100. So this middle line, it will contribute 90 degrees. So by keeping a scale, when you move gradually, you can mark the point like this. Right. The second point is at point 5, the angle is minus 94. So again between point 1 and 1 lies my point 5. So when you move up gradually, you see this is my point 5. So at this point 5 again the angle is minus 94. You can look at this side and by keeping a scale you can just mark the points. Right. Similarly for each and every point, every values we can mark it, and by using free hand we have to join this phase plot. So I'm just reversing the sheet, you see. Right, so this is my phase plot. Again while drawing phase plot you should always highlight your minus 180 degree line. It is mandatory. Right. So again we have to write the scale. So just depending upon the scaling you just write the values. Right. Now we are going to calculate the gain crossover frequency and phase crossover frequency. So how to calculate the gain crossover frequency? You see our magnitude plot is cutting the 0 dB line at a particular point. right? Can you see here? So at this point, what is the frequency? That respective frequency is known as gain crossover frequency, right? So here, this is the point, right? And when you look down gradually, you see what is the value of frequency? It is 10. So this is nothing but this is your gain crossover frequency, which is nothing but 10 radians per second, right? Now we are going to calculate the phase crossover frequency. Now look at this diagram. So how to calculate the phase crossover frequency? Our phase plot should intersect this minus 180 degree line. But here what happens? Here you see, let me zoom in and show you. You see, this is our minus 180 degree line. But our phase plot didn't cut the minus 180 degree line. So how to calculate the value of your phase crossover frequency? This is considered as infinity because our given plot didn't cross the minus 180 degree line, but we are assuming it will cut this minus 180 degree line at infinity, right? So we are assuming the value of phase crossover frequency as infinity, right? Now we are going to calculate the respective phase margin and as well as gain margin. So we know the value of gain crossover frequency, right? So at this frequency, you just draw a line here. So from this point, we are going to draw a line, right? So okay, this line is meeting our phase plot at a particular point, right? So at this point, note the respective angle. Just by keeping a scale here, you can note the angle. So here, at this point, the angle is somewhere around, you see, 124, 128, 132, 136, around some 136, right? So what is the formula for calculating your phase margin? So the phase margin is calculated as 180 degree plus pi gc, right? So here this is nothing but 180 degree minus the respective value is minus 136 degrees. So here the answer is 44 degrees, right? So how to calculate the gain margin now? So here our phase plot didn't intersect our minus 180 degree line, right? So here what to do? We are assuming the phase crossover frequency as infinity. So similarly, the gain margin should be also considered as some infinity, right? So whenever you are crossing the term infinity, then tell me about the stability of the system, whether the system will be stable or unstable. So here we are defining the system as absolutely stable system, right? So here comes the end of our problem. I hope you people understand the concepts very well. If you have any doubt, let me know in the comment section. Thank you.